For as long as humans have gazed up at the night sky, comets have been a source of fascination. These cosmic wanderers, with their glowing tails streaming across the heavens, have stirred a sense of mystery, wonder, and even fear. Ancient civilizations regarded comets as omens, harbingers of war, famine, or other great change. But as our understanding of the cosmos has grown, so too has our knowledge of these celestial visitors. Comets are not just mysterious visitors, they are remnants of the early solar system, carrying secrets of its formation, the origins of water on Earth, and even the potential for life itself. To understand comets is to understand the very foundations of our cosmic history. The journey of a comet begins in the outer reaches of the solar system, in a place that most of us can scarcely imagine, the Kuiper Belt and the Oort cloud. These are vast, icy regions that orbit far beyond the planets, at the edges of our solar system. It is here, in these cold, dark expanses, that comets form, from the frozen remnants of the material that came together to form the planets. Comets are made of ice, dust, and organic compounds, building blocks of life itself. They are the fossils of the solar system, unchanged for billions of years, preserving the conditions that existed during the formation of our cosmic neighborhood. They offer us a window into the past, into the birth of the solar system and the very origins of the planets. When the solar system was young, it was a chaotic place. The early solar nebula, a massive cloud of gas and dust, gradually collapsed under its own gravity, forming the sun and the planets. But not all the material was used in the formation of planets and moons. Some of it remained in the outer reaches, forming icy bodies that would become comets. These icy objects were scattered in all directions by the gravitational interactions of the newborn planets. Some were ejected from the solar system, while others were drawn into the cold outer regions, where they remain to this day, in the Oort cloud and Kuiper Belt. These distant regions are where comets spend most of their lives, drifting, dormant, and waiting for the gravitational nudge that will send them on their journey toward the sun. But what happens when a comet ventures into the inner solar system? As it gets closer to the sun, the heat begins to vaporize its ices, releasing gas and dust that form the characteristic tail we associate with comets. The tail, made of gas and particles, can stretch for millions of kilometers, glowing brightly as it is pushed away from the sun by the solar wind. This tail is not the comet itself, but the result of the interaction between the comet's ice and the sun's energy. It's a fleeting, glowing reminder of the comet's long journey, a brief spectacle that fades as the comet continues its orbit. But comets are more than just icy wanderers. They are time capsules. Unlike planets, which have been subject to geological processes and have evolved over billions of years, comets have remained largely unchanged since the solar system's formation. They are pristine remnants of the early solar system, carrying with them ancient chemical compositions that can tell us about the materials that were present in the primordial nebula. The study of comets allows scientists to glimpse the building blocks of the solar system, not just the elements that make up planets, but also the organic molecules that could have been critical in the origins of life on Earth. One of the most significant discoveries in the study of comets came from the Rosetta mission. Launched by the European Space Agency in 2004, Rosetta traveled more than 6.4 billion kilometers to intercept and study Comet 67P/Churyumov-Gerasimenko. In 2014, Rosetta's lander, Philae, made history by successfully landing on the comet's surface. This was the first time humanity had ever touched down on a comet, and it opened a new chapter in our understanding of these ancient wanderers. The data gathered by Rosetta revealed that the comet's surface is covered in a layer of organic compounds, complex molecules that are often seen as the building blocks of life. Scientists were astonished to find that amino acids, the building blocks of proteins, were detected in the comet's dust, suggesting that the ingredients for life may have arrived on Earth from space. This discovery has profound implications. Could comets have played a role in the origins of life on Earth? Some scientists believe they could have. The theory of panspermia suggests that life on Earth might have been kick-started by organic molecules delivered by comets or other icy bodies. These organic molecules, amino acids, sugars, and other key compounds, could have formed in the icy depths of the early solar system. And when comets collided with the early Earth, they may have seeded our planet with the necessary components for life to evolve. This theory raises the tantalizing possibility that life, or at least its building blocks, could be common throughout the universe, transported across vast distances by comets, asteroids, and interstellar dust. But the mysteries of comets don't stop there. The study of their orbits also provides clues about the formation of the solar system itself. The chaotic early days of the solar system, when planets were still forming and migrating, caused gravitational disturbances that scattered many comets to the outer edges of the solar system. Some were pushed toward the sun, while others were hurled into the far reaches of space. This explains why comets are not evenly distributed throughout the solar system, but are concentrated in specific regions like the Oort cloud and Kuiper belt. Understanding the behavior of these icy bodies allows scientists to piece together the complex history of the solar system's formation and evolution. As our technology continues to advance, so too does our ability to study comets in greater detail. Future missions like NASA's Comet Interceptor, set to launch in 2029, will study comets that are passing through the solar system for the first time, objects that have never been altered by the sun's heat, offering a glimpse into the pristine material from the distant reaches of space. These missions will expand our understanding of the chemistry and physics of comets, and will allow us to better understand how these ancient objects have remained unchanged over billions of years. But perhaps the most exciting future for comet exploration lies in our ability to capture and study cometary material directly. With missions like OSIRIS-RX, which collected samples from the asteroid Bennu, and JAXA's Hayabusa 2 mission, which returned samples from the asteroid Ryugu, we are beginning to gather more detailed information about the building blocks of our solar system. Comets, with their rich supply of organic molecules and primordial materials, could soon provide the key to answering some of the deepest questions in science. What were the conditions like when the planets first formed? How did water and organic molecules first come to Earth? Could we one day use cometary material to help sustain life during interplanetary exploration? As we uncover more about comets, we also uncover more about ourselves. The study of comets not only helps us understand the birth of our solar system, but it also forces us to confront the larger mysteries of the universe. The discovery of organic molecules on comets raises the question of whether life is a universal phenomenon, one that exists beyond our small corner of the galaxy. It challenges our understanding of life, chemistry, and existence itself. What does it mean if we are not alone in the universe? What does it mean for humanity to be connected to the stars, to the very building blocks of life scattered across the cosmos?